Hello everyone, this is Mohammad Wais from Jahangirabad Institute of Technology. I am a data science and business analytics intern at the Spark Foundation, and this is the first task of my data science and business analytics internship at the Spark Foundation. In this task, we are going to predict the percentage of an student based on the number of study hours with the help of supervised machine learning. This is my GitHub account, and here is the link, the Spark Foundation Task Data Science Internship. If you click on this link, you will enter in the task 1, which is already defined as predict the percentage of an student based on the number of study hours using machine learning. Now, here all details about the task is mentioned. Let's consider a scenario where we want to determine the linear relationship between the number of hours a student studies and the percentage of marks that a student score in an exam. We want to find out that given the number of hours a student prepare for a task, about how high of a score can the student achieve if we plot the independent variable as hours on the x-axis and dependent variable percentage on the y-axis. Linear regression gives us a straight line that best fits the data point. This task is divided in some steps, and the first step is to import required libraries. To import necessary libraries for this task, execute the following import statement, which is given below. After that, the importance of dataset. So the dataset being used for this example has been made publicly available and can be downloaded from this link, which is mentioned in the requirements. Now, this example was executed on a Windows-based machine and the dataset was stored in datasets folder, and you can also access it by URL. For reading Csv file, the following command: import the Csv dataset using pandas. Now let's explore our data a bit. To do so, execute the following script: dataset.shape. After doing this, you should see the following pointed out: 25, 2. That means that our dataset has 25 rows and 2 columns. Let's take a look at what our dataset actually looks like. To do this, use the head method. Head method is used for look at the first few elements of the output. The above method retrieves the first 5 records from our dataset, which will look like this. To see statistical detail of the dataset, we can use describe method. Dataset.describe that describe all the details in the dataset. And finally, let's plot our data point on 2D graphs to eyeball our dataset and see if we can manually find any relationship between the data. We can create the plot with the following script. Here, select column predicted and make to output to be a data frame. A column is known as predicted, which is printed it out. And after that, step 4, print a plot and visualize it with respect of x and y axis. In the script above, we use plot function of the pandas data frame and pass it the column name for x coordinate and y coordinate, which are hours and score respectively. The resulting plot will look like this. From the graph above, we can clearly see that there is a positive linear relation between the number of hours studied and percentage of score. Now, preparing the data. If you want both the rows and columns, then use. Now we have an idea about statistical details of our data. The next step is to divide the data into attributes and labels. Attributes are the independent variable while labels are dependent variable whose value are to be predicted. In our data set, we only have two columns. We want to predict the percentage score depending upon the hours studied. Therefore, our attribute set will consist of the hours column and the label will be the score column. To extract the attribute and label, execute the following scripts. The attributes are stored in the x variable. We specified -1 as the range for columns since we wanted our attribute set to contain all the columns except the last one, which is score. Similarly, the y variable contains the labels. We specify 1 for a label columns since the index for score column is 1. Remember, the column index start with 0 with 1 being the second column. In the next section, we will see a better way to specify columns for attribute and labels. Now we have our attributes and labels. The next step is to split this data into training and test set. We will do this by using scikit-learn built-in train test split method. Here, xtrain, xtest, ytrain and ytext we split out into two categories. Now, the above script splits 80% of the data to train set while 20% of the data to test set. The test size variable is where we actually specify the proportion of the set. After that, we are going to train the algorithm. We have split our data into training and testing sets, and now is finally the time to train our algorithm. Execute following command. After that, with scikit-learn, it is extremely straightforward to implement linear regression mode, as all you really need to do is import the linear regression class instantly. After that, we call the fit method along with our training data. This is about as simple as it gets when using a machine learning library to train on your data. In the theory section, we said that linear regression model basically find the best value for the intercept and slope, which result in a line that best fit the data. After that, we are making predictions. Now that we have trained our algorithm, it's time to make some predictions. To do so, we will use our test data and see how accurately our algorithm predicts the percentage score. To make predictions on the data set, execute the following script. In the step 5, compare the prediction model with the result. The Y prediction is an NumPy array that contains all the predicted value for the input values in the X text series. To compare the actual output value for X text with the predicted value, execute the following script. df equal to pd data frame actual data y test and predicted data y predict. Here we find the actual data in a column and predicted values also in a column, which is similar. Our model is not very precise. The predicted percentage are close to the actual one. In the sixth step, evaluating the algorithm. The final step to be available. The final step is to evaluate the performance of algorithm. This step is particularly important to compare how will different algorithms perform on a particular data set. Let's find the value for these metrics using our test data. Execute the following code. Here evaluating the model, and the requirement is 9.25. Testing the model with given data. After testing, we evaluate the model. The output will look similar to this, but probably slightly different. Here we predict mean absolute error and mean absolute error, mean square error and root mean square error. This task is completed by Muhammad Wais. Thank you for visiting my channel.